Recall our goal when solving equations is to isolate the variable. Essentially, we undo what has been done to the variable to isolate it. Balance of the equation must be maintained. In the previous video, we looked at the addition property of equality. This allowed us to move terms from one side of the equation to the other using addition or subtraction. With the multiplication property of equality, we will essentially do a very similar thing. This is used when the final variable term has a coefficient other than 1. It allows us to multiply or divide both sides of the equation by the same number. If a, b, and c are real numbers and we start with a equals b, then we could divide both sides of the equal sign by c, or we could multiply both sides by c. In these examples, we will use the multiplication property of equality to solve the equation and then check our solution. Up first, negative 7x equals 63. Notice the operation between the negative 7 and the x is multiplication. The opposite of multiplication is division. So to isolate the x, we will divide by negative 7. And if we do it on the left side, we need to do it on the right side as well. Negative 7 divided by negative 7 is 1. So we end up with 1x, or just x. And 63 divided by negative 7 is negative 9. From here, we can check our answer. We'll start with the original equation, and we'll make a substitution. We'll plug in what we think x is. Negative 7, replace x with negative 9, and we're asking, is this equal to 63? Negative 7 times negative 9 is 63. Notice we get a true statement, which means negative 9 is the correct solution. In the next equation, we have negative 4/10 x equals negative 16. Again, the operation between the coefficient negative 4/10 and x is multiplication. To undo that, we will divide by negative 4/10. And again, we need to do that on the other side as well. Here we get x equals 40. We can now check. We'll copy the original equation. And this time we want to replace the x with 40. And again, we're asking, is that equal to negative 16? Negative 4/10 times 40 is indeed negative 16. Since we get a true statement, we know 40 is the correct answer. In the next example, we have a fractional coefficient. Notice we have fractions on both of these examples, C and D. There's two approaches that we can take to solve these, and it doesn't matter which one you use. I'll show both techniques. First, we have 5/6 times x. To undo that, we divide by the coefficient, 5/6. If we do it on the left, we need to do it on the right side as well. Now on the left, 5/6x divided by 5/6, those fractions, they're the same. When we divide a number by itself, we get 1. So this is just x equals. Now we have a fraction divided by a fraction. Remember, the shortcut to simplify that is we keep the same first fraction, then we change division to multiplication, and we multiply by the reciprocal of the second fraction. We keep, change, flip. Keep the first one the same, change to multiplication, and multiply by the reciprocal of the second fraction. Now we can reduce before we multiply. 5 goes into itself once, 6 goes into itself once, and 6 goes into 18 3 times, leaving us with x equals 1/3. Again, we can check this. We have 5, 6. We're going to replace x with 1/3. And we're asking, is that equal to 5/18? 5 times 1 is 5. 6 times 3 is 18. And notice we get a true statement, which tells us 1/3 is the correct solution. Now there is an alternate way to solve this one when we have a fractional exponent. Let's see the alternate way in this example. In my opinion, the second method is a little bit faster. Instead of starting by dividing by 5/6, like we did over here, we could have multiplied by the reciprocal, which is essentially what we did down here. Notice we have 5/18, and then we changed this 5/6 to the reciprocal and multiplied. That's what we're going to do here. We're just going to do it without showing this division step. We will simply start by multiplying by the reciprocal. The first thing I'm going to do is just copy the original so I have space to write. And again, we could divide by -3/4 like we've been doing up here. But the shortcut when dealing with a fraction is to multiply by the reciprocal. So we're going to multiply both sides by -4/3. And notice what happens. -4/3 times -3/4 is just 1. And so we're left with x equals. And then over here we can reduce. 3 goes into itself once, 3 goes into 9 3 times. And then the 4 and the 14 have a 2 in common. So we're left with 3 times 2 is 6. 7 times 1 is 7. And then positive times a negative is a negative. So we get -6/7. We saved ourselves one step. Over here we divided by the coefficient and then we changed to multiplying by the reciprocal. We can essentially skip this first step and just jump straight into multiplying by the reciprocal of that coefficient on x. Make sure you do it to both sides, and the coefficient on x will always become a 1, which is what we want. We can still check. -3/4. Let's replace x with -6/7. And we're asking, is that 9/14? The 4 and the 6 have a 2 in common. We can reduce that right away. And 3 times 3 is 9. 2 times 7 is 14. Negative times a negative is positive. We get a true statement, which means -6/7 is correct. In these examples, we want to simplify first before we solve. Notice that 2x minus 12x, those are like terms. 2 minus 12 is -10. And we keep the x. That's equal to 40. Now, to isolate the x, we divide by -10 on both sides. X equals -4. We can check. Two times -4 minus 12 times -4. And we're asking, is that equal to 40? We get -8 plus 48 equals 40. 40 equals 40. That is a true statement, which means -4 is correct. In the next example, we can simplify on the right side. Notice that 15x and -5x are like terms, so we can combine those. 15x minus 5x is 10x. And now we have 10 times x. To undo that, we will divide by 10. And now 10 equals x. Let's check. Make sure we're right. 100. We're asking, is that equal to 15, replace x with 10, minus 5, replace x with 10. 15 times 10 is 150, minus 5 times 10 is 50. We get 100 equals 100, which again tells us our answer of 10 is correct.